This is my pre-algebra course. Today we're going to learn algebraic expressions. If you haven't done the homework from the last class, do that homework before watching this video. This is an important day in your math education because this is the first day that you're going to learn algebra. As I explained in the first class of this course, most of this course is algebra, even though it's entitled Pre-Algebra. Now, algebra is a type of math where you use letters to represent numbers that you don't know. Sometimes those letters are called unknowns. Other times those letters are called variables. The most common variable is x. X represents a number that we don't know. Other common variables are y and z. Now, if you want to add a variable, say 5 times, we don't want to have to write it 5 times. So what mathematicians do is they use the higher power form of addition. They use multiplication. So they write 5 times x, and we're using a dot for multiplication. But mathematicians use a more condensed form, and they write 5x, and they get rid of that dot. So whenever you see a number next to a letter, it means you're multiplying the number by the letter. Now, if you want to multiply x by itself 5 times, then we write that with power notation. We write x to the 5th power. Now, if you have 6 x's and you subtract 2 x's, then you have 4 x's. And if you have 3 x's and you add 7 x's, then you have 10 x's. And if you have 8 x's and you subtract 11 x's, then you have negative 3 x's. So as you can see, this math works much like the math that you learned in the previous classes. So let's get started. Number 1, 2x plus 7x. What do you think the answer to that one would be? If you said 9x, good job. And what about 11x minus 5x? If you said 6x, you were correct. And what about 4x minus 6x? If you said negative 2x, you were correct. So again, this stuff is pretty much the same thing you did in the last couple classes. So now something different is going to happen. Notice that this x does not have a number on it. If it doesn't have a number, it's assumed to be 1x, but we just don't put this 1. We just leave that 1 off there. So negative 5x plus x, that would be negative 5 plus 1. So see if you can figure out what that would be. If you said negative 4x, you're correct. All right, so how about number 5? See if you can do number 5. If you said 5x, you were correct. And if I'm going too fast, you can always pause the video and think about these problems more. But it's really, again, it's just the same thing we're doing in the last classes. How about number 6? 3y plus negative 6y. If you said negative 3y, you were correct. And what about 3y minus 6y? That's negative 3y again, but we just wrote it in a more condensed form. We got rid of these parentheses and this addition sign, and we just wrote it in that condensed form. So this problem is really the same as this problem. So how about number 8? If you said negative 5x, you were correct. And as you can imagine, number 9 is pretty much the same thing, just different notation. And be sure to rectangle your answers and be sure to write equal signs when you do your homework. All right, negative 2x plus negative 9x. What do you think that would be? If you said negative 11x, you're correct. Now, number 11 is just going to be a condensed form of number 10. We just got rid of the parentheses and we got rid of the addition sign. But like I mentioned in the last classes, this is the type of notation that really makes students nervous. But again, it's not that important. I mean, don't overthink it. It's just notation. So negative 2x minus 9x is the same thing as number 10. It's negative 11x. So now you try a problem where we have the condensed form here. Attempt number 12, and when you come back, we'll do it together. All right, we're back. So the answer should be negative 7x. Again, that's the same thing as negative 4x plus negative 3x. Again, it's just a condensed form. So now we go to the double negatives. These double negatives are going to become positives. Nothing is going to happen to this negative, but these negatives are going to become positives because they're right next to each other. So this would become 7x plus 5x, which would equal 12x. And this one would be negative 2x plus 4x, and that would be 2x. All right. So now it's time for you to try a problem. In fact, why don't you try numbers 15 through 19, and when you come back, we'll do them together. Pause the video. All right, we're back. I'm just going to write the answers real quickly here. And this one here is a little bit different because we don't have a number here, but remember, if you don't have a number, it's assumed to be 1. So negative 1 plus 7x, a negative 1x plus 7x is 6x. So if you got those answers, good job. All right, let me just double check to make sure I didn't make any arithmetic errors there. They look correct. All right, so why don't you try numbers 20 through 24, and when you come back, we'll do them together. Pause the video. All right, we're back. So you should get 0 on number 20, and negative 3y on number 21. And this one you would get negative 1x, but we don't have to write the 1. So you can just write negative x. It's not really wrong to write the 1, but mathematicians are going to look at you funny if you do that because it's just not necessary. All right, and 23 is the same problem pretty much, just a different notation. And 24 is going to be negative 8x. So if you got those answers, good job. All right. So now, why don't you try numbers 25 through 28, and when you come back, we'll do them together. All right, we're back. So as I do these, you can confirm that you're getting the same answers. So hopefully you got the correct answers. If you didn't, that's okay. Just go back and figure out what you did wrong. And it looks like everything is correct, so let's go on to the next problems. So I'd like you to try another problem set to get some more practice. So try numbers, why don't you go ahead and try, let's see here, try numbers 29 through 36, and when you come back, we'll do them together. All right, we're back. 13x, negative 3x, negative 15x, and negative 7x, and 6y, and 6x, and negative x, and 6x. So if you got those answers, good job. If you didn't, just go back and figure out what you did wrong. There's not really much to this. It's just basic addition. As you can see, the operations are not that difficult. What's difficult is understanding the notation and how to interpret that notation. That's what algebra is all about. The calculations will not be difficult, but the notation will be fairly challenging to interpret. So why don't you try numbers 37 to 42, and when you come back, we'll do them together. Pause the video. All right, we're back. I got 6x for number 37, and negative 15x for 38, and negative 15x for 39 also, because that's just a condensed form of 38. And I got negative 8x for number 40. That's just a condensed form again. And the double negative, whoops, accidentally gave you some answers there. Didn't mean to do that. Well, I guess I might as well just keep them there. I already got them there. It becomes 13y. And that becomes 3y. So if you got those answers, good job. All right, so now we're going to go to something a little more difficult. Now, I mentioned that adding and subtracting negative numbers is the most difficult part of this course, and that's what we're about to do here. The previous problems were not that difficult, other than the abbreviated notation. But when you put the numbers together, it becomes pretty challenging because there's a lot of opportunities to make a mistake. And sometimes it's hard to backtrack and figure out where you made the mistake. So let's do some of these problems together. We're going to keep the tradition to move left to right. So 6x minus 14x would be negative 8x. And then after that, it just reduces to the same problems we were doing before. So negative 5x. So we'll do some of these together, and you can try some on your own later on. So this is just an x by itself, but that means 1x. A lot of students will consider this to be 0x's. That's not 0x, that's 1x. 1x plus negative 6x is negative 5x. Negative 5x plus 2x is negative 3x. All right, negative 8z plus 9z is z. We can write a 1, but we don't really need to. It's typical not to write a 1 in front of there, in front of the letter, the variable, the unknown. Now this becomes a, well, let me just write it. So that double negative becomes a positive because the negatives are right next to each other. That's a double negative. And so we have z plus 2z for a total of 3z's. All right, negative 5x minus 10x is negative 15x. I know that's strange, but that's just their abbreviated notation. Don't overthink this. It's just abbreviated notation. It's condensed notation. You're just adding negative 5x and negative 10x. Do not overthink it. You have to learn the language. So just learn the language. It's like using the in the English language. You don't question why we use it. You just use it because that's the language. That's the word that we use. Negative 15x plus 4x is negative 11x. All right. So I think you're ready to maybe try one of these. So why don't you try number 47? And when you come back, we'll do it together. All right, we're back. Negative 3x plus negative 12x is negative 15x. And negative 15x plus negative 2x is negative 17x. So if you got negative 17x, good job. All right, now 48 is the condensed notation. So this is gonna cause probably some maybe some nervousness. Negative 3x minus 12x is negative 15x. And then negative 15x minus 2x is negative 17x. So that problem was actually the exact same problem as the problem above. But it was just a condensed form. We didn't use the parentheses, and we didn't use the addition signs. So again, this is just adding negative numbers, but it's a condensed form, and it really makes students nervous and confused. But there's no reason to be confused. Just learn the language. That's how we write the sum of negative numbers. Why do we write it that way? I don't know. Nobody knows. We just write it that way. I can come up with possible explanations, but it was a collective decision, as far as I know. All right, so why don't you try 49, and when you come back, we'll do it together. All right, we're back. Negative 2x plus 4x is 2x, and I'm just going to rush through this because I don't want to bore you. And if you got negative 6x, good job. All right, try number 50, and when you come back, we'll do it together. All right, we're back. So we have a double negative, so that becomes a positive. This is a double negative. So now that we got rid of that double negative, we're going to add 6z plus 3z to get 9z. And this is interesting because we're actually going to get 0 for our final answer. So if you got 0, good job. If you didn't get 0, just figure out what you did wrong. All right, number 51. Attempt that problem, and when you come back, we'll do it together. All right, we're back. Negative 4x plus negative 2x is negative 6x. Negative 6x plus x is negative 5x. So if you got negative 5x, good job. All right, number 52. Go ahead and try number 52, and when you come back, we'll do it together. All right, we're back. And we got negative 5x. So if you got negative 5x, good job. Why don't you try the next two problems, and when you come back, we'll do them together. All right, we're back. So we got negative 15x. If you got negative 15x, good job. Remember, this is the condensed notation. I could write it without the condensed notation, but you need to get used to that notation. All right, 54. Seems like we're coming up with 15 quite a bit. That's just a coincidence. All right, so if you got negative 15x, good job. And number 55, you can see what's going to happen. It's just the condensed notation, so it's exactly the same as number 54. That's just going to give us negative 15x. But just to show my work, because remember you have to show your work and your homework, there you go. All right, number 56. Go ahead and try number 56, and when you come back, we'll do it together. All right, 2x plus negative x, that would be x. And then x plus 9x is 10x. So if you got 10x, good job. All right, try numbers 57 and 58, and when you come back, we'll do them together. All right, we're back. So I got 0 for that one. If you got 0, good job. First step, I'm going to get rid of this double negative. That becomes positive. And then we end up with 4z. So if you got 4z, good job. All right, try number 59, and when you come back, we'll do it together. All right, we're back. So if you got negative 17z, good job. All right, we're getting a lot of practice here. Now you might start saying that I'm becoming bored, but don't complain. You need to do all these problems with me because this is going to prepare you for the homework. If you get stuck in the homework, it's probably because you're not doing these problems with me. All right, so try numbers 60 and 61, and when you come back, we'll do those together. Pause the video. All right, so we get negative 5x. Now we get negative 6x. So if you got negative 6x for number 60, good job. It looks like this is another condensed form where you get the same answer. I put a lot of these problems right next to each other on purpose so that you would understand that they're the same problem. It's just this form is a condensed form of this form. It's very important to understand that. That's a cause of a lot of confusion. All right, number 62. Now we've got 4 numbers, four terms. These are called terms, by the way. The first term, the second term, the third term, so on and so forth. So why don't you try 62, and when you come back, we'll do it together. All right, we're back. So 7x minus 4x is 3x. And 3x plus negative 2x is just x. And x plus negative 3x is negative 2x. So if you got negative 2x, good job. All right, so why don't you try number 63. When you come back, we'll do it together. Pause the video. All right, we're back. Negative 11x minus 4x is negative 15x. And negative 15x plus 8x is negative 7x. And the double negative becomes a positive. So now we have negative 7x plus x is negative 6x. So if you got negative 6x, I'm proud of you. Good job. Again, we're learning the language of algebra. It's extremely important. All right, attempt number 64. When you come back, we'll do it together. All right, we're back. So if you got negative 18x, good job. Again, I'm working left to right here. All right, try number 65, and when you come back, we'll do it together. All right, we're back. All right, number 66. If you got negative 15x for 65, good job. On to 66. Go and attempt number 66, and when you come back, we'll do it together. All right, we're back. And again, we've got negative 15x. That's just a coincidence that we're getting so many negative 15x's. All right, number 67, go and attempt number 67, and when you come back, we'll do it together. All right, we're back. Hopefully you're getting a hang of this by now. You can't learn algebra overnight, but you can learn it over time. All right, I'm going to write an equal sign. This is very important. I cannot go down anymore. I don't have any room, but I can write an equal sign over here. That's perfectly legal. I cannot write an equal sign over here because that's reading right to left, but I can write an equal sign here and write my answer over here. That's perfectly fine. That's legal. And we got a negative 15x because, again, I'm trying to demonstrate that this is just an abbreviated form of this notation. Again, this is the notation that's going to make this, that this is the most difficult thing in this entire course, is understanding this abbreviated notation when you're adding negative numbers. All right, let me just double check that. Seems good. So on to number 68, and it looks like we're done with adding and subtracting algebraic expressions. Looks like we're on to multiplication. So we already talked about multiplication a little bit. When you multiply x times x, you get x to the second power. It's very important to understand that x to the second power is not the same thing as 2 times x. These are very different things. So in these problems, we're going to be multiplying x's. For example, x times x is x to the third power. But we're going to be multiplying powers. So for example, we'll have x to the third power, and then we'll put times x to the fourth power. So we have 3 x's multiplied together, and we have 4 x's multiplied together, and we're using parentheses for multiplication. Remember that? We learned that you can use parentheses for multiplication. Of course, you can also use dots. Now, I could have written a dot, but that would be too easy. We have to get used to the parenthesis notation. So x to the third power times x to the fourth. So those x's, there's 3 x's multiplied together, and there's 4 x's multiplied together. And if you multiply them all together, you get x to the 7th power. You just add the powers. Now that really makes students nervous. They don't understand why you're adding the power, but I just explained why you're adding the power. It's very simple. You have 3 x's that you're multiplying, and then you multiply those x's by 4 x's. So now guess how many x's you're multiplying? 7. You just add the powers. So that's the explanation for all that. So I'm going to get rid of this so we have room. Maybe I should keep that upper part there. All right, so this is going to be very easy. It's not difficult at all. We know this is multiplication because we see the parentheses, and there's no addition sign in between these. If there were addition sign between these, then that would be adding the expressions. But since there's no addition and the parentheses are right next to the other number, we know it must be multiplication. Now, there's one thing that I didn't talk about in the previous problems. If you have something like 5x plus 3y, you have different variables. You cannot add those up. They do not add to 7, something or other. They don't. You just have to leave this expression the way it is. So the only way that you can add terms is if they're like terms. But that's not the case with multiplication. With multiplication, you can combine the letters. So this is going to be very easy. First, we multiply the numbers. -3 times 6. Now, we know 3 times 6 is 18. At least I hope you know that from your multiplication facts. If you don't know that, then you're in some big trouble. Go back and learn those multiplication facts now, and learn them fast. And I mean real fast. Learn all 36 of them in about 1 or 2 days, and then come back. We also learned in the last classes that a negative times a positive, those are unlike signs. They don't like each other, so it's a negative situation. We put a negative. So we already learned how to do -3 times 6 is -18. That's nothing new. We learned that in the previous classes. But what we didn't learn is x to the 2nd power times x to the 7th power. So as I just explained over here, x to the 2nd times x to the 7th would just be x to the 9th. You just add the powers, and that's it. That's all we're doing. It's very simple. It's simple as that. You're just learning the notation. You have to learn how to do this. You have to learn the language of algebra. 6 times -7, that's -42. And then y to the 3rd times y to the 1st power, that's considered to be a 1st power, even though there is no power. Just like y is considered to be 1y, y is also considered to be y to the 1st power. Now, it does take some explaining to tell you why it's considered to be 1 power, but it should be fairly obvious, at least on face value. So 6 times -7 is -42. Again, we know 6 times 7 is 42 because of our multiplication facts. And we know that a positive times a negative is a negative because they're unlike signs. We have a positive and a negative. Unlike signs, so they don't like each other. It's a negative situation. Again, you don't have to remember that cheesy story if you don't want. You can just remember that unlike signs are negative and like signs are positive when you multiply or divide. So now, y to the 3rd power times y is y to the 4th power. Very easy. And I forgot to rectangle my answer there, so we'll get that one there. All right. So now it works the same way when you have more than one letter. Again, you cannot add different letters. You can't combine them. But with multiplication, you can combine them to a certain extent. -8 times 2 is -16. And x to the 2nd power times x to the 3rd power is x to the 5th power. And y to the 5th power times y to the 6th power is y to the 11th power. As you can see, this stuff is really easy. But you have to differentiate between addition, which we did over here, and multiplication, which is what we're doing here. So remember, when you see these parentheses right next to the numbers, that means multiplication. You're learning the language of algebra right now. That's the purpose of this. All right, -3 times -4 is +12. This is the first like sign that we've had so far. Negative times a negative is a positive. X to the 2nd power times x to the 3rd power is x to the 5th power. Y to the 4th times y to the 9th is y to the 13th. And z to the 5th times z to the 6th is z to the 11th. And that is our final answer. Let me double check that. Everything looks good. On to the next problem. All right. So if you want to, you can try the next problem. And when you come back, we'll do it together. All right, we're back. We have like signs, -9 and -6. So multiply those. You're going to get a positive 54. Y to the second times y to the 8th is y to the 10th. And notice that these numbers don't have to be in the proper, they don't have to be in any kind of order. The y comes first on this one, the y comes second on that one. That's okay, it doesn't matter. You still combine the y's and the x's and so on and so forth. X to the first power times x to the second power is x to the third power. And z to the 6th times z to the second is z to the 8th. And I'm just double checking that. Everything looks good. So if you got 54, y to the 10th power, x to the third power, z to the 8th power, good job. And now we have three terms that we're multiplying. So we have to multiply -2 times 5, and that gives us -10. And x to the 4th times x to the 3rd is x to the 7th. So I'm just adding those powers. So I multiplied the first two terms, and I'm going to do this by steps. And then you multiply, and you get -10 times -10 is positive 100, because those are like signs. And x to the 7th times x to the 7th, you just, again, add the powers, so it'd be x to the 14th. So if you got 100, well, actually, we didn't do that. We did that one together. All right, so on to the next one. You're going to have a chance to do some of these on your own more, but right now we'll just do them together. 3 times -4 is -12. -12 times 6, that's not our multiplication facts, but that would be, I've been doing this for a long time, so I know that that's 72. 72, and then x to the 6th times x to the 11th would be x to the 17th, and then y to the 17th, and then we don't have a z, it looks like. All right. And let's see here, just double checking that. Looks correct. On to number 75. I got -30. 5 times -3 is -15. -15 times 2 is -30. 15 times 2 is not one of our multiplication facts, but you can figure that out. I got y to the 13th power if you add all those y powers. And x to the 7th. So you can do these along with me if you want. Looks like that's correct. And we have -9 times, now this is an interesting problem here. This is something different, because we have a little negative sign there, but there's no number next to it. Again, that's accepted to be -1. So you have -9 times -1. So 9 times 1 is just 9. And then 9 times 3 is 27. So we get 27, and then you just multiply the variables, the letters that is, and we get z to the 12th. And y to the 16th, and x to the 8th. All right, let's see here. That looks correct, just double checking that. Everything looks correct. All right, number 77. 4 times 2 is 8, times negative 3 is negative 24. Negative 24 times 2 is negative 48. That's not one of our multiplication facts, but again, it's not that difficult for you to do. X to the second times x is x to the third, x to the fourth. So again, you're just multiplying all these x's. And that's a negative 1. So I just realized I forgot that negative 1. So that's going to change our sign. See a sign here? That's going to change our sign to positive. So be careful about those signs. I almost made a mistake right there. It's very easy to make a mistake with these problems. All right, so x to the 4th power, and then y to the 2nd power. We have 1y here and 1y here, so you multiply them together and you get y to the 2nd power. And then our x's, actually we already did our x's, so the z's, I think that would be z to the 4th power, because you have 1z, or you have 3 z's here and you have 1 z there. So that would be z to the 4th power. All right, so now it's time for you to try some problems. We'll start with some easier ones. Again, we're just multiplying. So why don't you try numbers 78 and 79, and when you come back, we'll do those together. All right, we're back. Negative 5 times 3 is negative 15. X to the 4th times x to the 5th is x to the 9th. You just add those powers on the x's. You've got the 5 and the 4 on the x's, so you just add them up and you get a 9. So if you got negative 15x to the 9th, good job. And we have 6 times negative 8, which is negative 48. And x to the 1st power times x to the 5th power is x to the 6th power. All right. Let's see here. All right, so if you got negative 48x to the 6th power, good job. So number 80, we have more than one letter. So go ahead and attempt number 80, and when you come back, we'll do it together. All right, we're back. Negative 2 times 3 is negative 6, and that would be x to the 9th. We got 9 x's again, and then y to the 9th. So if you got that answer, good job. And try number 81, and when you come back, we'll do it together. All right, we're back. Negative 5 times negative 4 is positive 20. And combine the x's and the y's. And if you got 20x to the 7th, y to the 9th, good job. All right, attempt number 82, and when you come back, we'll do it together. All right, we're back. Negative 3 times negative 8 is positive 24. Then we get x to the 6th. Then we get y to the 3rd. And z to the 9th. Again, these are expressions where you're multiplying all of these together. And a lot of students would say, I don't like this, this is boring. Well, it might be boring, but you're accomplishing something very important. You're learning the language of algebra. That's the biggest task in your entire K-12 education, is learning the language of algebra. All right, so why don't you try 83, and when you come back, we'll do it together. All right, we're back. Negative 3 times 2 is negative 6. Negative 6 times negative 1 is positive 6. Because again, this is considered negative 1. And we have x to the 7th. And y to the 5th. Be careful. A lot of students will not see this y here. There's only one of them, but it's still there. And we have z to the 10th. So if you got that answer, good job. Again, be sure to write your equal signs and be sure to rectangle your answers. All right, 4 times negative 3. Why don't you try 84, and when you come back, we'll do it together. All right, we're back. 4 times negative 3 is negative 12. Negative 12 times negative 5 is positive 60. That's not one of your multiplication facts, but you can do that on paper if you need to. We learned how to do that. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. Plus 1 is 6. So you get 60. Or you can just use a calculator, because in this class we really don't care about your arithmetic skills nearly as much as we did in the last course. So the purpose of this class and this course is to teach you the language of algebra, not to bog you down with complicated arithmetic calculations. All right, so let's see here. X to the 12th we get. And then y to the 8th. And it looks like that's it. So if you got 60 x to the 12th, y to the 8th, good job. All right. So we're moving right along here. We have 3 more multiplication problems, so go ahead and attempt 85, and when you come back, we'll do it together. All right, we're back. Looks like we get negative 12. So if you got that answer, good job. Why don't you try number 86, and when you come back, we'll do it together. All right, we're back. Now this is a negative 1, so that's going to change the sign. So negative 2 times negative 1 is positive 2. Positive 2 times 2 is 4. And z to the 14th. X to the 12th. And y to the 2nd. All right. 3 times negative 1 is negative 3. Well, I'm sorry, go ahead and attempt 87, and when you come back, we'll do it together. That's kind of a monster problem there. All right, we're back. 3 times negative 1 is negative 3. Negative 3 times 2, I should be highlighting this as I'm saying it. 3 times negative 1 is negative 3. Negative 3 times 2 is negative 6. Negative 6 times negative 3 is 18. 18 times 2 is 36. So that was a lot of problems there. That was a lot of calculations. So 36. And 18 times 2 is not one of our multiplication facts, so I'm sorry for putting that in there, but you're going to have to get used to doing some of these calculations in your head eventually. So we get x to the 7th. And y to the 13th, it looks like. let's see here, z to the 17th, it looks like. So that was a monster problem there, but if you got the right answer, I'm proud of you. If you didn't get the right answer, that's okay. Just go back and figure out what you did wrong. So that's multiplication. Notice we had parentheses. You show multiplication in algebra with parentheses. So now we're going on to dividing algebraic expressions. And we talked about how to show division in the last class. In algebra, you most often show division with a fraction symbol. So what this means is you're taking negative 20x to the 4th power and you're dividing by 5x to the 2nd power. So it's just the same, it's the same thing. And you can write it in this notation, that's fine, but it's more common to see it in this notation, so we're going to write it in the more common notation. Now, when we multiplied variables, well, first of all, let's go ahead and divide these numbers. So negative 20 divided by 5. If you know your multiplication facts, you should know how to do that problem very easily. We know that 5 times 4 is 20, so we know the answer is going to be 4. And we know that the same rules apply. We have unlike signs, a negative 20 and a positive 5. So unlike signs, they don't like each other. It's a negative situation, so we put a negative on the 4. Now, when we multiply variables, we add the powers. If we divide the variables, division is the opposite of multiplication, so you guessed it. If we divide the variables, we subtract the powers. So it's going to be 4 minus 2. So you get x to the 2nd power, negative 4x to the 2nd power. Another way of thinking about it is you're multiplying 4 x's on the top and you're multiplying 2 x's on the bottom, because that's what powers mean. You're multiplying the x's. And these 2 x's here, they cancel out. 2 x's in the top, and you're left with 2 x's in the top. So that's another way to think about it. All right. And that's going to come in handy in the next problem. In the next problem, we're going to divide, but the problem is if you divide, then we're going to come up with some sort of a weird a decimal. So this is a problem where all you really do is just simplify this fraction. So let me explain. We have 18 over negative 28, so all you're going to do is just reduce that fraction. And you're going to reduce it with the fundamental principle of fractions. So remember the fundamental principle? You can multiply both sides of a fraction by the same number, and you'll get an equivalent fraction. And that will make the numbers bigger. But you can divide both sides of a fraction by the same number, and you'll get an equivalent fraction, but that'll make the numbers smaller. So that's what we're going to do here. We're going to reduce this fraction. So we're going to divide both of these numbers by 2. 18 divided by 2 is 9, and 28 divided by 2 is 14. That wasn't one of our multiplication facts, but that's okay. And when I say our multiplication facts, I mean the facts that you learned in the last class. I'm assuming that you took my arithmetic course. If you already knew enough arithmetic for the prerequisite for this course, then that's okay, though. All right, so now if you subtract the powers, 3 minus 7 is going to give you a negative number. So all that means is that your x's are going to end up on the bottom. So let me explain what that means. You're multiplying 3 x's on the top, and you're multiplying 7 x's on the bottom, right? 1, 2, 3, 4, 5, 6. I need one more. 1, 2, 3, 4, 5, 6, 7. So what this means is you have 3 in the top. So those 3 are going to cancel out 3 in the bottom. But in the bottom of the fraction, that's the key. In the bottom of the fraction, you're going to be left with 4 x's. So what this means, let me move this over. What this means is that you're going to be left with 4 x's in the bottom. Not in the top, in the bottom. And of course you have your negative sign. That doesn't go away because a positive divided by a negative is still a negative. And you can write the negative here, you can write it here, or you can write it here. But it's very unorthodox to write it in the denominator. Usually you would either write it in the numerator or right next to the fraction. So that's the answer. 9 over 14. 9 over 14x to the 4th. All right, let's do another one of those. Actually, I should probably just leave that. All right, negative 22 over 8. Again, this is a problem where we can't really divide because we're going to end up with a decimal. So we just reduce the fraction. We divide both of these numbers by 2. 22 divided by 2 is 11. 8 divided by 2 is 4. Now we have a negative divided by a negative, so those negatives are just going to go away. And then we have x to the 7th over x to the 5th, so we can just subtract and get x to the 2nd power. So there are more x's on top than on the bottom, which means that the leftover are going to be on the top. Now here we have more x's in the bottom, so the leftover are going to be in the bottom. The key is how many do we have left over once we can't try to cancel out the y's. So there are 5 y's on top and 8 y's in the bottom. These 5 y's are going to cancel out 5 on the bottom, and you're going to be left with 3. So again, these 5 y's cancel out 5 y's down here. I'm going to say that again. These 5 y's cancel out 5 y's down here, and you're left with y to the 3rd power. Now we could say 5 minus 8 is negative 3, but I don't want to talk about negative powers because that gets kind of weird and complicated. So hopefully you understand what's going on. If you don't, that's okay. We're going to do some more problems. All right, let me rectangle that. Number 91. So we can just reduce negative 6 over 12. Divide both sides by 6, and we end up with, let's see, 6 divided by 6 is 1, and 12 divided by 6 is 2. Now we're not going to put a 1 here. Well, I guess we can put a 1 for now, but we're going to take that 1 away, as you're going to find out. And we have an x to the 1st power. If there's no power on the x, that's assumed to be 1st power. So we're going to subtract these powers, and there's more x's on top. So 3 minus 1 is 2, and the x's are going to be on the top. Now, this is an unusual situation we haven't encountered yet. The powers are the same. If the powers are the same, then they're just going to disappear altogether. And the 1, of course, I'm just going to take that off, and I'm going to move that x over so it looks more symmetric. And there we go, negative x squared over 2. So if you're thinking to yourself, I don't know about this, this seems like a lot of stuff that we're learning. Well, it is a lot of stuff. Algebra is not easy. It's not something that you're going to learn overnight. You have to take it step by step. You have to take it lesson by lesson, homework assignment by homework assignment, and that's the key. When I tell you to do the homework assignments, do them. They're not optional. They're required. If you don't do the homework assignments, then you will learn nothing. I promise you, you will learn nothing. That's my guarantee to you. So you have to take it homework assignment by homework assignment by homework assignment. All right? Nobody in the history of mankind has ever learned algebra without doing homework. All right, number 92. We have 40 divided by negative 8. Now that's going to give us a whole number. 40 divided by 8 is 5. And a positive divided by a negative is a negative. So that's going to be negative. Whoops, I got to put my equal sign here. And 4 minus 3 is x, and there's more x's on top, so that's going to end up on top. I'm going to move that up a little bit. And y, there's more y's on the bottom. So if we subtract 2 minus 1, we get 1, but the 1 is going to be, the y is going to be in the bottom because there's more y's on the top than on the bottom. And here we have more z's on top than on the bottom, so our z's are going to end up on the top. These 4 z's are going to cancel out 4 z's here, so you're going to be left with, if you cancel out 4 z's here, you're going to be left with 5 z's because 9 minus 4 is 5. So again, I know this is a lot for you to remember, but hopefully you're getting the hang of this. All right, we're going to do one more together, and then you're going to start doing some on your own. Here we have a negative divided by a negative divided by a negative, so it's going to be positive. So these negatives just cancel out, and we can reduce this fraction. So what number, again, we're going to use the fundamental principle of fractions. What number goes into 28 and 63? Well, if you know your multiplication facts, it's not that difficult to figure out. 7 goes into both those numbers. So 28 divided by 7 is 4. 63 divided by 7 is 9. Very easy. All right, so x to the 5th over x to the 2nd is x to the 3rd. Y to the 8th over y to the 10th. That's going to be y to the 2nd in the bottom. And this is going to be z in the bottom. Let's see here. That looks all correct. So we'll go ahead and rectangle that. And now it's time for you to try. So go ahead and attempt number 94, and when you come back, we'll do it together. All right, we're back. A negative divided by a positive is a negative. 40 divided by 5 is 8. And there are more x's in the top, so it's going to be x to the 2nd power. And how did I get 2? Because I did 7 minus 5. All right, so why don't you try, well, if you got negative 8x squared, good job. Why don't you try number 95, and when you come back, we'll do it together. All right, we're back. So first of all, a negative divided by a negative is a positive, so we know our answer is going to be positive. And what number goes into 28 and 30? 28 and 30, I think 2 is the only number that goes into those, so that's not our multiplication. That's not one of our multiplication facts. But if you divide both those numbers by 2, and by the way, you can use your long division algorithm if you don't want to use a calculator. So you get 14, or you can just use a calculator because, again, the purpose of this course is not to bog you down with difficult arithmetic. So if we divide both those numbers by 2, we get 14 over 15. Again, we're using the fundamental principle of fractions. There's more x's on the bottom, and the difference between 4 and 7 is 3. So we have 3 x's left in the bottom. So if you got 14 over 15 x cubed, good job. And notice how I called this number cubed. You can say to the 3rd power, or you can say cubed. And you might hear me say x squared also. I may have said that already. I'm sorry if I confused you, but you'll learn later on why that's called x squared. You can call it x to the 2nd power, x, or x squared, and you can call x to the 3rd power x cubed. Again, it's not that important at this point why we can do that. I think I may have mentioned that in the last course. All right, number 96. Go ahead and attempt that problem, and when you come back, we'll do it together. All right, we're back. A negative divided by a negative is a positive, and 28 divided by 4 is 7. And that reduces to x to the 8th, and this reduces to y to the 7th, or excuse me, y to the 2nd power. So if you got that answer, good job. All right, on to number 97. You're doing good so far. Just keep it up. All right, so try number 97. We're just going to reduce this fraction by using the fundamental principle of fractions, and when you come back, we'll do it together. All right, we're back. So we're going to divide both sides of the fraction by 3, and you get 4 over 5, and a negative divided by a positive is a negative, so you can put the negative there. And we have 1x in the bottom, and looks like it's going to be 8y's in the top. So if you got that answer, good job. All right, try number 98. When you come back, we'll do it together. All right, we're back. 77 divided by 11 is 7. And our answer is going to be negative x to the 4th, y to the 3rd, z to the 2nd power. So if you got that answer, good job. All right, number 99. Attempt number 99, and when you come back to it, we'll do it together. Use the fundamental principle of fractions to reduce reduce that fraction. Pause the video. All right, we're back. A negative divided by a negative is a positive. We can divide both these numbers by 5 to get 5 over 7 x squared y to the 7th and z in the bottom. So if you got that answer, good job. All right, so number 100 is going to be slightly different, so let's try this problem together. A negative divided by a positive is going to be a negative, so we know our answer is going to be negative. And we can divide both these numbers by 6. 6 divided by 6 is 1. And 48 divided by 6 is 8. And then we have x to the 2nd power and y to the 4th power. Now, the reason that this is different is because notice that usually we don't write a 1. We just kind of get rid of it. But if we get rid of this 1, look what happens. There's nothing in the top. We can't do that. You have to have something in the top, because if you have nothing in the top, that means 0, and 0 over a number means 0. We learned that in the last class, that if you have 0 in the numerator, the fraction is 0, but we don't want 0. So we have to keep that 1 in the numerator. So that can be a source of problems for students, because when all the numbers end up in the bottom, they're not sure what to put in the top. Or, in most cases, what students are going to do, they're going to write the answer like so. They're going to say that this is the answer. That's not the answer. It needs to be 1 over that. That's the correct answer. That's a big source of confusion for students. So let's go on to number 101. See if you can try number 101, and when you come back, we'll do it together. All right, we're back. We're going to divide both these numbers by 2, and you get 1. Actually, let me space that out a little better. First of all, we're going to have a negative number. Hopefully you've learned the rules with negative numbers. I don't have to keep saying it over and over again. So we're going to end up with 2 divided by 2 is 1. 8 divided by 2 is 4. We have an x in the bottom and 2 y's in the bottom. So because there's nothing on top, you have to write that 1 on top. Technically, there is something on the top. Whoops, used the wrong thing there. So if you got that answer, good job. So again, these problems are a little different because the numerators have 1. And they have just 1, and that's it, nothing else. All right. It's these types of problems that typically cause students quite a bit of frustration. Let's see here. I think that's all correct. So why don't you try 102? When you come back, we'll do it together. All right, we're back. So you should get 3 in the bottom. And 1 on top. And there you go. So if you got that answer, Good job. All right, try number 103. When you come back, we'll do it together. All right, we're back. Divide both these numbers by 10. 10 divided by 10 is 1. 50 divided by 10 is 5. And, oh, these 8s, they all cancel out. They disappear completely. And we're left with three y's in the bottom. And there you go. All right, 104. Go ahead and attempt 104. The difference for these problems is that we're going to have some variables that are going to cancel out. That's pretty much the only difference for these problems. So go ahead and attempt 104, and when you come back, we'll do it together. All right, we're back. So I can divide both these numbers by, let's see, by 6, it looks like. 24 divided by 6 is 4. Actually, let me move that over. I know our answer is going to be negative. So 24 divided by 6 is 4, and 54 divided by 6 is 9. All right, then I end up with 1x in the bottom, and these y's just cancel out completely. So if you got that answer, good job. All right, so on to the next one. A negative divided by a negative is a positive. 14 divided by 7 is 2. And those x's just cancel out because they have the same power. And you have one of the y's in the bottom. So if you got that answer, good job. Try number 106, and when you come back, we'll do it together. All right, we're going to divide both these numbers by 6. 6 divided by 6 is 1. And 42 divided by 6 is 7. And my answer is going to be negative. And we're going to end up with 2 x's in the bottom, and the y's just cancel out. So if you got that answer, good job. All right, try number 107, and when you come back, we'll do it together. All right, we're back. We're going to divide both these numbers by 9. 72 divided by 9 is 8. 81 divided by 9 is 9. And the x's just cancel out, and the y's cancel out too, because they all have the same powers. So you're just left with 8/9. All right, we're almost done here. I'm really proud of you for sticking it out this far. You're going to move very quickly through this curriculum, quicker than just about anybody in the world. So I'm really proud of you for sticking it out. All right, negative 45 over 5. And go ahead and attempt that problem, and when you come back, we'll do it together. All right, negative 45 over 5 is negative 9. And all the other variables just cancel out because they're all, the x's all have the same power, and the y's all have the same power, and the z's all have the same power, so they just disappear. All right, number 109, attempt that one, and when you come back, we'll do it together. All right, we're back. Negative 30 divided by negative 6 is positive 5, and we have the same situation. All those variables are just canceling out. All those letters. Attempt number 110, and when you come back, we'll do it together. All right, we're back. We can divide both these numbers by 7, and we get 2. I guess I'll put my negative on the 2 just to save time. So 14 divided by 7 is 2, and 21 divided by 7 is 3. And the variables just cancel out again. So you're left with negative 2/3. Maybe I should write that a little neater. Negative 2/3. All right, So the last two problems are just my attempt to explain to you that you can use the older division sign also. You may see the older division sign in some problems. It's no big deal. You just do 36 divided by -9, and that would be -4. And x to the 5th divided by x to the 3rd, you just subtract, and you would end up with x to the 2nd on the top because the dividend has more x's than the divisor. And then y to the 7th divided by y, that would be y to the 6th, same explanation there. So it's the same principle when you're using the older division sign. All right, so now we go on to 112. And I think I'm going to need to shrink this a little bit so we don't run out of room. Now 35 and 56, again, I don't think you're going to see this notation very much, to be honest with you, so you don't have to worry about it, but you just consider it to be a fraction. So you're going to divide both these numbers by 7. 35 divided by 7 is 5. And 56 divided by 7 is 8. And a negative divided by a negative is a positive, so we don't have to worry about a negative sign. And x divided by x, they both have the same power, so they just disappear. And y divided by y to the 3rd, well, there's more y's in the bottom, that is the divisor, than the top, the dividend. Again, the dividend is just considered to be the numerator, and the divisor is considered to be the denominator. So we have y to the 2nd in the bottom. And I know what you're thinking. You're thinking, why is it that division is considered to be why is it considered to be a fraction? Why is it the same? Why is 2 divided by 3 the same thing as 2/3? Well, it's actually very simple. If you have two wholes and you divide, well, I should probably use rectangles. So you have two wholes. They're supposed to be the same size. They don't really look like the same size there, but I think you get the point. And you divide these two wholes into 3 equal parts. Each part will be 2/3. So each one of these parts is 1/3. So this is 1/3, and this is the 2nd third, and this is the 3rd third. So the size of each part is 2/3. That's how you measure it. It's 2 out of the whole, which is 3/3, is 2/3. So if you take two wholes and you divide it into 3 equal parts, the size of each part, each color, is 2/3. And I know that's not exactly simple to think about, but that's why a fraction sign is considered to be the same thing as division. It's not really something that students think about. College students don't think about. High school students don't think about it. You don't have to think about it. Just know that a fraction sign means division. Most people graduate from college, and a lot of people even earn mathematics degrees without ever really thinking about why a fraction sign means division. So it's not something that you really have to think about. All right, so wait a second. I'm sorry. I forgot my 8 there. I'm sorry if I confused you with that. I just double-checked that. 5, 8, and that's it. So that should be the answer. All right. So it looks like we're done with the class today. That was quite a bit of work, so I'm very proud of you for getting through that. Now, if you'd like to take a screenshot of all the work we did today so that you don't have to go back to the video, and you can put these screenshots in your notes, here's the work that we did. You can take a screenshot of all that, or you can take a screenshot of closer pictures here. So the first 2 pages and the 3rd and 4th page. And then the 5th and 6th page. And again, that will make it to where you don't have to necessarily go back to the video to see how to do these problems. That will help you, these screenshots will help you with the homework. So this is the homework. Go ahead and get screenshots. This is screenshot number 1 and screenshot number 2. Now I know that seems like a lot of problems, but these problems you can do pretty quickly. So don't be discouraged by this many problems. Be sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. And for these problems, you really don't have to show a lot of work. In fact, you really don't have to show any work, because you can just get the answer by doing it in your head. But you need to cover these answers. Don't look at them. Be sure that you can figure out the answer, and then check it after you produce the answer. And again, title your paper, put your name, date, the course, everything, and you need to keep this in order in your binder. You need to keep a record of your homework. So that said, I'll look forward to seeing you in the next class.